All right, so the first thing we're going to learn about is the determinant of a matrix. So if we have an identity matrix, right, for any square matrix where you have ones across the diagonal, the determinant of that matrix is going to be 1. We can find the determinant of any 2 by 2 square matrix with the following formula. And the way that I like to think about it is you multiply along, we'll start with blue. Multiply along this diagonal, you'll get A times D. If you multiply along this diagonal, you'll get B times C. And the diagonal that's going backwards will always be negative. And you add that together, and that is the determinant of a matrix. So if we go back here, if you multiplied this way, you'd get 1. If you'd multiply this way, you'd get 0. And if you subtracted those two, your determinant would be 1. So I'd like you to find the determinant of these two. Check how you did. Determinant of the first one is 17. The determinant of the second one is 0. So you can only find the determinant of square matrices, and so far we've only learned how to do the 2 by 2s. If a matrix has a determinant of 0, it has a special name. We can highlight that right now. It's called a singular matrix. And it's important because if a determinant is 0, that means that it does not have an inverse, which is going to be coming up important for what we're going to be doing later on today. So to find the determinant of a 3 by 3 matrix, you get the following formula. Isn't that a nice formula? You think you can memorize that one easily for your exam? So what does this mean? First of all, these straight lines mean the determinant of the 2 by 2. So you take A, multiply it by the determinant of this 2 by 2, subtract B, and multiply it by the determinant of this 2 by 2, plus C. Now, as far as seeing the formula a little bit easier, what you have is, for this first one, which I'll put a green box around, you have A. So if you ignore what's left in that row and that column, this is the determinant that you have in that box. Now, if I color code this one next, what you have is B. Whoops, that's yellow. If you ignore everything in those ones, it's B times the determinant of D, G, F, and K. And finally, if we color code this one in black, you have C, and then you're multiplying by the determinant of what's left. Now, for the most part, I find that if I have to remember that formula, it gets complicated. It takes a long way. Just like the straight lines is really easy to remember and figure out, we can do that with the 3 by 3 as well. So what we'll do is we will take our 3 by 3 matrix and rewrite the first two columns again right there. This will make 3 diagonals going this way. 1, 2, 3. And 3 diagonals going backwards. again, these ones, once you add up all of these ones together, you'll subtract them from those ones. And I find this is easier to do than working with the formula. So we'll do this one together. If I rewrite the first two columns, 2 times 2 times 2 is 8, 0, 4, and backwards, 16, 0, negative 2. So if we add the blue ones up first, you're going to get 12. Subtract, add these ones up, 14. We get negative 2 in the end. So here's one for you to try. Yeah, I can go back. So the determinant is 30. So what I'd like you to do now is to type this 3 by 3 matrix into your calculator. And then we're going to look at some calculator things that can check it as well. So your calculator has the determinant built in as an operation. So if we go second, matrix, edit, 3 by 3, 3, 0, 3. So once you've entered that matrix in, under matrix, if you go to math, it gives you a bunch of different things you can do with matrices. Now the first one is determinant, so we can go determinant of matrix A that we just put in there. And the calculator tells us that it's 30 as well. So that one can be used to find your determinant, to check if you got it right. Number 2, the transpose, if you would like to rewrite your matrix in a different order, that sometimes can be helpful if you type something in wrong. Like when we were doing the word problems the other day, if you typed in a matrix and then realized, oh, I needed to do a column matrix instead of a row matrix, well, that transpose button can change that matrix right away for you, and then you could restore it. But that one isn't as helpful or as useful. And this one we will look at a fair bit later on, but this one that says Aurora Ref stands for reduced row echelon form. And when we solve matrix equations later on, we'll have to reduce it to reduced row echelon form. And this is another nice way to check to see if your calculations are right.